Let's move on now and look at arithmetic series. A series is simply the sum of a sequence, and the reason that this is an arithmetic series is because the terms in this series form an arithmetic progression, as in the constant difference here is always 4. How do we add these things together? Well, let's imagine this visually. Here I have my first term, and then constant difference to my second, constant difference to my third, and so on and so on. If I duplicate this and start moving the positions of these terms, what we see is we create effectively a rectangle, where the width of that rectangle is the number of terms that are in my sequence, and the height of that rectangle is the same as the first term and the last term added together. How do we apply that? Well, in this example, if I'm to take this series and to write it down the same but backwards, I've got 41 plus 37 plus 30, 3, and so on, until I get 9 plus 5. Now if I add all of those things together, pairwise, I end up with 46 plus 46 plus 46 plus all the way through 46 and 46. How many lots of 46? Well, the same number of terms that I have in this series. Now, how do I find that? Well, I know that the last term, un, is going to be 41, and I know that the first term here was 5. I also know that the difference is 4. So I can then solve that 5 plus n minus 1 lots of my difference is equal to 41. Or n minus 1 lots of 4 is equal to 36. Dividing through n minus 1 is equal to 9, or rather n is 10. So there are 10 terms in this series. Now I'm going to introduce a new notation now to say that this is going to be the sum of the first 10 terms in my series. And this is also the sum of the first 10 terms in my series, just written the other way round. If I add those things together, I get 2 lots of the sum of the first 10 terms in my series. How many terms did we have? Well, we've said that we've got 10, so 2 lots of the first 10 terms adds up to 10 lots of 46, which is 460. So the sum of the first 10 terms in my series is going to be 230. Now let's look at how we can create the general formula for this. This is something that you need to not only know, as in the end result of this that you need to know, but you need to be able to prove it from the start. So you would need to be able to replicate what I'm about to write down. So we would say that the sum of the first n terms is going to look like this. It's going to be a plus d plus a plus 2d. So all I'm doing at the moment is I'm just writing out the general form of a series for an arithmetic series, plus, and then I have a bit of a gap, and then I add on the last term, which is a plus n minus 1 lots of my difference. Now that's with my sequence written out one way. What am I just going to do is tidy things up here. It seems my pen is no longer wanting to work as well as it should do. I'm now going to write the same thing down, but I'm going to write it out backwards. So a plus n minus 1 lots of the difference plus a plus n minus 2 lots of the difference plus, and so on all the way through until I end up with the first term at the end. Now, if I take these two lines and I add them together, then 2 lots of the sum of the first n terms is going to be, add these terms together, a plus a gives me 2a plus, there's nothing to collect there, so that's going to be n minus 1 lots of the difference, plus, I've got 2 a's again, plus, well, this comes out to be also n minus 1 lots of the difference, which is exactly what we should expect because that's what we've just seen on the previous page. So we've got the same thing written down everywhere here, 2a plus n minus 1 lots of the difference. How many times am I adding that together? Well, I'm adding that together n times, so this would become n times by 2a lots plus n minus 1 lots of the difference, and that's going to give me twice the sum of this arithmetic series. So the sum of the arithmetic series is simply a half of that result. 2 lots of the first term plus n minus 1 lots of the difference. Now there is a slightly different arrangement of this formula, which I'm just going to show you now by writing this down as follows: a plus n minus 1d. Now this goes back to what I was showing you in the previous diagram here, where this is my first term, a, and this is my last term, L. Now to generate that last term, what do I need to do? I need to do a plus n minus 1 lots of the difference. So another way of thinking of this general formula is that it's the first term plus the last term, or thinking of it as 2a plus n minus 1d. So these are the two versions that you will need to know again from memory. As I say, this is first term plus last term, but that's the same as writing down 2a plus n minus 1d. Let's look at how we use this then. To find the sum of the first 20 terms of an arithmetic series that looks like this, I would start off by stating very clearly that the first term here is 47, and I can see that the difference here is going to be minus 3. So what do I then want to do? Well, I would then write down that the number of terms that I've got is 20, so I would then say that the sum to 20 is going to be n over 2 lots of 2a plus n minus 1 lots of the difference. What does that give me? That gives me 10 lots of 94 minus 19 times 3, and at this point I resort to my calculator, or I'm very quick at mental maths. We've got in here 370, so the sum of those first 20 terms is going to be 370. In the last example we look at something a little bit different, so here I want to find the least number of terms required so that this series exceeds 1000. So this is using the same information but just in a slightly different way. So I'm going to start off by writing down the information that I know. So I know that the first term here is 5. I also know that the constant difference here is going to be 6. And I know that I want this to exceed 1000. So I'm looking for n. N is the thing that I'm not sure about. So I want to find when Sn is greater than 1000. Well, to make this question a little bit easier, let's try and find out when Sn is 1000. So when would that happen? Well, that would be when our sum, which would be n over 2 lots of 2a, which is 5, plus n minus 1 lots of the difference, which is 6, will be equal to 1000. We want to try and find that point. Now, just a quick algebraic manipulation, that's going to be 10 plus 6n minus 6 is going to be 1000, and again tidying that up a bit further, that would be n over 2 lots of let's say 6n plus 4 is equal to 1000, and then expanding that is going to give me 3n squared plus 2n is equal to 1000. Now at this point we should also recognize that this is a quadratic equation. So how do we solve quadratic equations? We want to first of all set them equal to 0, so I'm going to bring that 1000 across to this side, and I'm going to look at trying to solve that. And I think the easiest way to do that is going to be using the quadratic formula, so that's going to be minus 2 plus or minus the square root of 4 minus 4 times 3 times minus 1000, so that makes that plus 1000. All over 2a, which is going to be 6. Now, I know that n here has to be a positive number. How do I know that? Well, because it's referring to the number of terms that are in a series, and I can't have that to be a negative number, so actually I don't need to bother calculating that negative value. I only need the positive value. So I then throw that into my calculator, and it tells me that n would be equal to 17.927 something or other. So the sum would be exactly 1000 when the number of terms in the series was 17.92 something or other. Well, we know that that can't be the case because the number of terms in our series either needs to be 17 or 18. It needs to be a natural number, it needs to be an integer. In fact, it doesn't need to be a natural number because it can't be negative. So what do we do now? Well, we want the least number of terms for it to exceed 1000. If n was 17, it wouldn't yet exceed 1,000. It would be less than 1,000. So in this, we need to then take n to be 18.